Hi, this is Bob from INSYDIUM. In this video, we'll recreate this crystal growth using MeshTools and Cycles 4D. So here we are on a new scene. Let's create the bit of geometry that we're going to base our MeshTools animation on. So we're actually going to do that with a Terraform FX landscape, but a very low poly one. So let's go to the INSYDIUM menu, to Terraform, and let's pick the Terraform terrain object. We'll get rid of these two filters which come in automatically, the erosion filters. Let's delete those. Let's go to our terrain object and we'll deselect the display. And with our segments, we don't need many segments at all. Let's just try 20 by 20. We'll hit ND to see the lines. So yeah, something like that's looking okay. And what we want to do is we will disable enable Phong shading, because what we want to do is see these angular changes of the polygons. We don't want them to be smoothed by the Phong shading. All right. So what we're going for here is we want to deform this terrain object enough so we get some really contrasted light and shadow areas. So to visualize that, let's just bring a light into the scene to help us. So we'll bring in a light and let's just put it quite low down, say over here. And this light, we're going to set the shadow type to soft. We'll go to the Options tab and select Shadows for our viewport preview. And let's hit NB to show that shading. So now you can see, look, we're getting these really dark shadowy areas. Let's just go to that shadow and reduce its density to say 70. All right. So now we want to deform this plane a little bit. So let's go to our noise. And instead of this turbulence, let's pick a wavy turbulence instead. And we will go to the Operator tab. Let's increase the gain up to, say, 80. So now we're getting some very distinct areas of light and shade. And that will do us for now. So what we're going to do with that, let's just right-click on the terrain and let's click Current State to Object. And that now just gives us a polygon object. So then we can switch off this and make it invisible and just forget about it for now, but we can go back to it and make a different terrain later should we wish. Let's just switch our light off as well. All right, so this is our terrain. And what we're going to do is create a nice MeshTools kind of extruded animation that looks a little bit like kind of crystal growth. So what we want to do, first of all, is we want a couple of things. This is going to look nicer if we have fewer polygons to start with and if it was triangulated rather than quads. So the way in which we're going to do that, let's go to this menu here and we'll bring in a Polygon Reduction object. And then let's make our terrain a child of that reduction object. You can see, look, it's reduced those polygons and it's triangulated the mesh. So let's switch our light back on and have a look. We're getting these nice shadowy areas which are going to help us at render time. Because what you're going to see with this technique is that the actual geometry animation doesn't look particularly special until we light it and texture it at render time. But what we want is highly contrasted areas, some bright, some in shadow. That's looking pretty good. So let's take that, and again, just to kind of like keep this so we're able to make adjustments should we wish, let's right click on that poly reduction. Let's click on current state to object, which then gives us this null with the polygon object below, so we can just take that out. Let's delete the null. Let's switch off the poly reduction and make invisible everything in that hierarchy. So again, we're not looking at it, and that can be something that we can go back to and refer to should we wish. So just to keep things tidy, let's just select both of these disabled hierarchies and hold Alt and press G. which groups them in a null. And let's just call this scene geo. And then we know we can come back to that should we need to later. But now, if we just switch that light off, now we've got this geometry that we're going to use with our mesh tools. And because we've kind of deformed it in the way in which we have, we've got these random bits of angled deformation, which are going to give us really nice light and shade at render time. Okay, let's just get rid of that light now. Right, so now we can look at mesh tools. So let's go to the INSYDIUM menu and we have mesh tools here. So let's go and we'll just click on these dotted lines and then we'll hold on the dotted lines and let's dock them here. And then we'll hit the right mouse button, icon size, large. And our mesh tools, we have these objects. So what we're going to do first is we want to subdivide these triangles. So let's, with the terrain object highlighted, let's hold Alt, and then we're going to click on the Mesh Tools Subdivider. And it automatically becomes a child of the subdivider. And you can see that that subdivider has done just that. It's subdivided these triangles. If I switch it off, there we go, switch it on, it's subdivided them. Let's go to the Object tab of the subdivider, and it's subdivided them once. We've got one subdivision. If we increase that, we've got more, and we can keep going and going. But actually, one is going to work well for us. In fact, let's go for two. Let's go for two, why not? Now this has been applied to the whole mesh, so every original polygon is being subdivided. But what we're able to do with mesh tools, this is procedural, so we can use noises to dictate what parts of the geometry are subdivided. And to do that, it's really simple. All we need to do is go to our shader, let's bring in a noise, and now you can see, based on this noise, some areas aren't subdivided and some areas are. Excellent. And let's go into our noise. We could animate this. Look, let's give it an animation speed of 1, hit play, and now you can see that that subdivision of our object is live and it's animating along with that noise. We don't want to do that for now. Let's just increase the scale, and then we're going to go to our subdivider, to the Object tab, and if we increase the tolerance, you'll see we'll get fewer subdivisions. If we decrease it, we'll get more subdivisions. So let's increase that a little bit, something like that. It's looking good. All right, very nice. And we could even try, look, so we've tried increasing. Let's try decreasing that global scale. And now it's a little bit more patchy. So I think on second thoughts, this is going to look nicer. And let's go back to the Object tab, increase the tolerance to make it more patchy. So now we've got some areas that are subdivided and some that aren't. All right. So now we're able to layer this up and do some more changing of our geometry in a procedural way. So with the subdivider selected, let's hold Alt, and we're going to bring in an inset. So let's bring that, and you can see the subdivider has become a child of the inset. And what you'll see here is that nothing has changed. Well, that's because the inset is set to 0 at the moment. So let's go to its settings, Object tab, and we have the amount set to 0, so we're not seeing anything. But as I increase this amount, if you look in the viewport, you'll see that we're getting an inset polygon per existing polygon. You see that? And if we put it up to 100%, it goes to a point. Or we can come down. So let's just dolly in a little bit so we can see this inset. We'll go right up to this polygon here, and I'll just adjust that percentage amount. So this is it on 0. This is what the geometry was like. And then we're creating this inset. And what's cool about this is we can then offset this. So let's offset this by 1. And this is kind of creating an extrude. So that's looking pretty nice. And with both this amount and this offset, we're able to hit variation. So if we give it variation of, say, 49% on the amount and 49% on the offset, and now we've got a much more kind of random offset and amount. And obviously that becomes more obvious the more the greater your offset is. If we put that on, say, 10, some of them are going to be sticking way up, some of them aren't so much. Let's put that back down to 5. All right, so that is looking pretty good. Now, again, MeshTools is procedural, so we can do some pretty cool animation stuff with this, including the use of fields. So if we go to our inset, and if we go to the fall off tab, let's bring in a spherical field. And now what you'll see is, if we move this field out of the way, we're only getting that inset. If I just dolly in a little bit as well, we're only getting that inset when it's in the bounds of the field. And when it's in this inner bounds, it'll be kind of at 100% strength. And you can see that it effectively animates on. So the inset animates and the extrude, the offset animates on as well. So that is pretty neat. All right. Very cool. So now what we're going to do is we're going to layer this up. So let's, with our inset selected, let's select another inset. So we'll hold Alt, click on that, and it becomes a child. And now what we can do is create a second layer of insets. So let's just switch off our fields for now, and we'll go to the fall off and just deselect that. Okay, so with our new inset selected, let's go to the Object tab. We'll just dolly in so we can see. So now if we increase the amount, you'll see that every new polygon now is getting its own new inset. And we can, of course, have an offset amount as well and have those extrude up. So let's put it on, say, 4 and 50. And we could put some variation on those as well. Let's put 49% and 49%. So we can get incredibly intricate geometry very quickly and easily, and we can animate it on. So let's go back to our first inset. We'll go to the fall off tab. Let's reactivate that sphere and click it on here. And what we want to do is we want, with our new inset, we want to have a fall off sphere as well. So let's bring in a new sphere. And we want this one to come in kind of after this first one. So let's kind of put it somewhere about there. We'll keep it a little bit smaller. And we will make this one a child of our original, which just means it'll keep its animation. We only need to animate one of them. So now what you're going to see, if we get our parent field, we're going to get the first, let's just dolly in a bit, we're going to get the first inset animating on, and then as our next field comes along, we're going to get that secondary inset moving along. Now, you can see a little bit of movement in and out here, and this happens when you're layering up more than one field, and it's about the way in which the new vertices are created under the hood in MeshTools. So the way to avoid that kind of flickering as new vertices are created in different parts, all we need to do is go to the first spherical field, go to the remapping, and it needs a bit of a start value. It doesn't want the start value to be on 0. So if we put this min up to, say, 8%, and now if we move that along, you'll see that all of that has gone, and we're just getting this first part of the inset, and then the secondary inset comes along as it goes into that other field. And we could perhaps take that second field and just move it along ever so slightly. All right, so there we are. Relatively simple. We have set up very quickly this procedural modeling animation based on our terrain object. So now what we need to do, now that we have this, we need to set this up, we need to light it, we need to get a camera in the right position to make this pretty plain looking scene look like that stunning render. So let's set up Cycles 4D then, so we can start getting this lit and we can get a camera in the right place. So we're going to go to INSYDIUM, Cycles 4D, and let's start the real-time preview render. So this will preview in real time, as the name suggests. So if we get that going, you'll see that we have got a black screen. Let's just go to Render and select Fit, so it will fit the viewport in whatever screen size we have, but we're seeing a black screen, and that's because there are no lights in the scene. So let's go to the INSYDIUM menu, and let's go to Cycles, and we'll bring in a sky. And now you'll see that we are starting to render what's in our viewport. It doesn't look quite right just yet. So before we go on, let's just dock this real-time preview in our layout. So we'll grab these 3 lines here, click and hold, drag it, and then let go, and now it is docked. There we go. And you can see if we move our camera, now we can see our geo. Now, this is not looking quite right. Remember that we didn't want any Phong shading when we created our terrain-based geometry, but this looks like it is using Phong shading. It's all smoothed, and we need to switch that off. So the way in which we do that is we go to the object that's being rendered, in this case, the highest object in our MeshTools hierarchy, this inset, and we go to Tags, INSYDIUM Tags, Cycles 4D, and we bring in an object tag. And then on that object tag, we're going to, look, we have a smooth shading option. Let's deselect it. And now we're getting that unsmoothed shading, which is kind of what we were expecting. Okay, very nice. So if we just go into the viewport and move around here, you can actually see that we have a sky object in our scene, and there's a sun, and that is what's providing us with this nice render. Now, there are no materials on anything at the moment. This is just the sky that's giving us this kind of light and shade. Now let's find, what we want to do is find a camera angle that's going to look nice here. And my eye is kind of concentrating, if you have a look in the viewport, at this area here. What we want is some nice sharp kind of changes in angles, which are going to create some nice light and shade areas. So what we'll do is we'll get a camera in here and we'll try and find an angle that we like. Before we do, let's just go to the sky. We'll go to the sky settings, and here we can set the various different settings for where the sun is in the sky, how high it is and how powerful it is, and then what the kind of atmospheric conditions are like in relation to the atmosphere, the dust, the ozone, all that kind of thing. So let's just rotate this round by, say, 180 degrees. There we go. And so we've got a nice bit of shadowing in here. Let's just go maybe back to 175. And then let's lower that elevation so it's kind of earlier in the day or later in the day. Let's go to, say, 6 degrees. So now there's some really interesting, very shadowy elements. That's perhaps a little bit too much. Let's go to, say, 9 degrees. And we'll just reduce that sun intensity down to, say, 4. All right. So we're starting to get some really kind of contrasty areas in our model here. So let's start setting up a camera. So we're going to go to INSYDIUM and we'll go to Cycles and we'll bring in a camera. And you'll see that this is just a standard Cinema 4D camera with a Cycles camera tag attached to it. So let's click on that so we're looking through it. And now we can position this in our viewport. And we're thinking somewhere around this kind of area is looking pretty nice. We're wanting some of this light and shade, you see. So let's just have a little look. About this bit here. And obviously we're going to make some adjustments to this. But let's leave it there for the time being. Okay. So now that we have our camera there, Cycles 4D is fantastic at rendering depth of field really quickly, and we can use some nice depth of field effects in this render to our advantage. So to set that up, let's just go to our real-time preview, and here we have a focus picker. So if I click this, and then we want to focus in this kind of light area is going to be our hero section. So let's click on there, which has focused that camera to this area. So now if we go to the camera tag and we go to the depth of field aperture, the aperture set to radius. So we just increase this aperture and you can see, look, it's been blurred out and this bit's in focus. We don't need that much. We want this to be quite subtle. So there we go. Very nice. And if we go to our spherical field, our top parent spherical field, go to the coordinates, and let's just move that along on the X. You can see that that's making our MeshTools fields animated animation happen. And we're getting all of this really nice detail coming through into the scene. Now, one thing that has become obvious is that our final kind of animation position wants to have as much of the subdivided areas in the center of this animation as possible. So we perhaps need to move this field along in the Z a little bit, and then this X-axis is going to be how this animates through. And right at the end is when we get most of that detail. Now, looking at it now here, I think arguably our second layer of insets could be poking out a little bit more. So let's go to our inset, our top one. We'll go to the object tab. Let's offset that by, say, 8 or even by 10. Yeah, that's looking better. And arguably, look, this is all procedural, so we can adjust things on the fly. Let's go to our subdivider and let's give it more subdivisions. So let's click the subdivider. Now there's loads more subdivisions. Little bit too much now. We've got too much detail going on here. So to sort that out, let's just increase that tolerance a little bit. So there's less of that subdividing going on. And that's looking pretty neat. Okay, so now that we have got this basic render and our basic area in which we're going to render, let's think about how we are going to texture this. And it's actually a very simple texture. That's what it's doing is quite complex, but with Cycles 4D, like many of the shaders, it's really easy to set up. So what we're going to do is go to Cycles 4D, and we're going to go to surface, and these are all preset surface textures. So let's go to principled Bsdf. Click on that, and here we have it here. Let's drag this principled Bsdf onto our inset object, the top one. And now this is what is coloring our object. So let's double click on this, and now we get the fantastic Cycles 4D node editor. And at the moment, all we have is this output is basically our object, and we have this principled shader going into the surface of that object. We can put materials and shaders into the volume of objects. We can also give them displacement and alpha information, but for us, we just need to do the surface. Now, the principled Bsdf shader is a kind of a do-all shader. It can do a basic diffuse material, and that's similar to what we're seeing now. So if we put the roughness up to full, now we can just alter this base color to make whatever basic diffuse material we desire, and it'll update in our viewport. And of course, we can give inputs into that color and get incredibly technical with very large node trees, but we could also keep it simple. But for our scene, all we're going to do is give this just under a mid-gray for our base color. But now what we're going to do, and this is the trick that's going to make this look fantastic, is we're going to use subsurface scattering. Now, what subsurface scattering does, it gives you the effect of light penetrating an object's volume and spreading out, basically scattering inside that volume. And so subsurface scattering affects, if you don't know already, things like if you imagine a candle. When you light a candle, you can see that light scattering inside the wax, and it looks a little bit like it's glowing. That's a good example of subsurface scattering. So to switch that on, we're just going to turn subsurface scattering to full. And by default, the subsurface scattering has this colour. And we'll leave it on that colour for now. But now we need to address the radius X, Y, Z. And this is how the different lights is being scattered in the volume. So let's just, if we highlight our principled shader here, you can see its attributes also in our regular Cinema 4D attributes manager. So let's reduce the radius at which that light can spread on the X, Y, and Z, which is the RGB. So let's try 0.1. Obviously it's spreading too much at the moment, so it's just glowing everywhere. We've got no geometry definition. So let's put it on 0.1, 0.1, and 0.1. So that's looking a little bit more interesting. We've now got some of that contrast back. Let's reduce that roughness down, which will give us some specular back. And now we're getting some nice specular here. The colour is not right for us. We're going to go into the, in fact, look, let's go to the colour channel here. If you go into this colour channel within the attributes in the pull down menu, it'll update in real time. And what we want is, we want a kind of nice colour like this, something along those lines. All right. So now let's try. There's nothing that says that all of these different colours, the Y and the Z and the X, have to have the same radius value of scattering. So let's try putting the Y and the Z down so it isn't able to scatter as far. And that's giving us this nice kind of pronounced glow and hue of our base colour, but it's flattening out a little bit, which is bringing in a little bit more detail. Now, this is looking quite nice, but by default, the principled shader uses the Christensen-Burley subsurface scattering model. But there is another one which is far more physically accurate called random walk. So Christensen-Burley is kind of an approximation of how the light would scatter in the volume, whereas random walk is a far more realistic, uses a far more realistic algorithm to actually work out how that light would scatter. And as you can see, we're getting a very, very nice effect now. Arguably, we could reduce that saturation so it's not quite as pronounced. That's looking pretty good. Okay. So we can close our material editor. We'll leave our material at that for now. And let's just see if we can make some tweaks to this scene. So what we will do, let's just pause our real-time preview. We're going to come out of our cycles camera and let's animate our fields, because at the moment they're not animating. So our end position needs to be at frame 90. And what we want to do, let's just hit NA so we can see those fields a bit more clearly. What we want to do is get our fields, and we want them to kind of be in this position right at the end of the animation, because we want all of that subdivided behavior to be happening right in front of the camera. So something like that. So let's go to our spherical field, to the coordinates tab, and let's put keyframes in the X and the Z. And then we'll go back to the first frame. And here we need to move these out of the way. So it's animated on. And we'll just try a keyframe there. Right, so let's go back into our camera. let's hit the real-time preview. So now you can see in the foreground, we have none of that inset subdivision or very little of it. And in the background, it's come through. So arguably, we could move that spherical field a little bit further back. All right. And then let's keyframe those again. So let's just switch off the real-time preview, hit play, and we'll view it in our viewport. And there we've got our subdivided coming on. Okay, and let's restart our real-time preview and have a look at some different frames. So at the beginning, we've got our mesh as is, and as it comes on, we start getting it subdividing. Now arguably, we're seeing this well in the distance, and it's subdividing, and it's taken quite a long time in our scene to get to the point where we're seeing it in the hero area, the foreground. So one strategy to make this look a little bit more dynamic would be, let's just come out of that camera, switch off that real-time preview. One strategy would be, instead of having our field animate from here towards the camera, let's have it start here and animate across the camera, and then we're going to get that effect a little bit more quickly. So what we will do is we're going to right click, we're on the spherical field, let's right click on the Z here, animation, and we will delete track. So we've taken away all of those Z position keyframes. Let's move the field into the correct Z area, and we're going to go to frame 90. So something like that. Okay, let's just go into our camera, start our real-time preview. So this is the end frame. Do we have all of the subdivided area in that camera view that we want? Let's move it across a bit. Yeah, so we need to have that a bit closer because we want all these bits to have been divided by the time we get to the end. So something like that. I think we could extend the inner part of this field. So there we're getting all of that detail now right at the end. That's looking better. So now we can re-keyframe that X. That's where it's going to be. Now let's come out of the camera again, switch that real-time preview off, go back to the first frame, and now it's going to move on like this. Now, that may be still too closely into the shot, but let's have a look. We'll go into our camera, start the real-time preview. All right, so we're starting with a little bit of subdivided going on, but not too much. And then it's coming across this way in a wave. And we're starting to see it happen and kind of come across our geometry here. That's looking really nice. Very cool. Let's just go to our subdivider, and we increased these subdivisions. We've got an awful lot going on here, arguably a little bit too much. Let's just increase that tolerance, which will just reduce the amount of very small pieces. Yeah, so now we're getting a little bit more interesting variation there. That's looking nice. And we'll just go to our sky. Let's go to our sky tab. And let's just try just playing around with the elevation. So we'll try just reducing the sun elevation a little. It's obviously too much. So this is going to give a more kind of shadowy, dramatic look. We could, if we're going to go this way, we could increase the intensity. So this is obviously putting less of our material into the light. That's looking pretty cool. So let's just go back, sun intensity to 4, and we'll just try a slightly higher elevation than we had before. So I'm preferring the higher elevation because we're getting these really nice specular hits here, which is giving us some nice, interesting detail. And of course, we can control and adjust contrast of shots in post. So this is looking nicer. Let's maybe go back to say 9 degrees sun elevation. And that's looking really cool. Okay, so let's just pause that interactive renderer. So what we have now is we have our animation, we have our camera set up. So the only thing to do is we're going to add a little bit of camera animation, and we're going to then do our render settings. So to animate our camera, we're going to do a really simple camera move. So what we're going to do is we're going to rotate the camera, but not the camera itself. We'll rotate a null, which will make control easier, and it means that we are not having to mess around with the camera coordinates, which can get confusing. So the way we're going to do it is this. Let's just come out of that scene camera. What we're going to do is, in the kind of area where we're focusing, which is around here, we're going to place, well, we're going to place a null, but actually to help us place that null, let's bring in a sphere into the scene. We'll make this sphere a lot smaller. So there's a sphere. Let's hit ND so we can see the lines. Okay, so this sphere we're going to kind of place in the approximate location we want our null to be. So that's something like that. Let's go into the camera now. So this sphere, the center of which is where we're going to be rotating this. So here's our kind of hero area. So it's going to be somewhere kind of like that. That looks good. Okay. So with that sphere, we're going to make it invisible. And then we're going to put our camera as a child of the sphere. And now, if we go to the sphere, go to coordinates, and animate the heading, our camera is going to pivot and rotate on that point, which is very neat. Something like that. Okay, so that's looking good. Let's put that back to 0 where we were. So then, let's just have a think about how we're going to position this. So let's start somewhere like this. And hit a keyframe. And that keyframe, we're at frame 83. So ideally, we should have started that at the beginning. So let's drag that to frame 0. Go to the last frame, go to our sphere, and now we can decide where we're going to finish up. And we're going to finish up somewhere like this. Hit a keyframe. So now when we hit play, you'll see that our camera has got that nice animation move around our hero area of this animation. Very nice. So let's just go on to our real-time preview. And we'll go back a bit. So what we could do at this point, remember we're filling our real-time preview with whatever is in our viewport. And of course, these areas on the top aren't going to be rendered. These are our letterbox areas. And so we need to make sure that we've got this camera set up appropriately and not be put off by whatever is in this view, which actually isn't going to be in our render. So to do that, we can go to Render, Uncheck Fit, which will show us the actual size, but now it's zoomed in a little bit too much, so we can reduce this zoom down to, say, 30%. So this is the actual view that we're going to have. Let's have a look. 30% is perhaps a little bit small. Let's go to 50. That's better. So now we have got our animation coming through. Nice. Now, arguably, I think we're a little bit too close because some of these areas up here, which are now obviously cut off, had some nice kind of definition of light and shade. So let's just go into our camera. This is the beauty of nesting the camera in an animated sphere. We can just go into our camera and we can just pull out a little bit. And now it's still animated as it was. We're going to have to change the focal point, but now we have got a little bit more in the frame. Let's move forward to kind of here. Yeah, and that's looking really cool. Now we've got these nice kind of hits in the background and that contrast, so that's really good. So let's go to our focus picker and just re-pick this hero area to make sure that we're fully focused in that area. Okay. And that's looking great. All right, so let's just pause that. So now we're pretty much there. We have got our animation sorted, our camera sorted, we've lit it, and we have sorted out a camera animation. So the final thing that we need to do now is we need to sort out the render settings for cycles. So let's just switch off our real-time preview. We can get rid of that, and then we'll start looking at our render settings. So let's go to render, and we'll go to edit render settings, and let's have a look. So what we'll do is we'll click off save. We're just going to render to picture viewer for now, and we'll go to renderer, and we want to pick cycles 4D. And let's go to output, and we want to render. Let's just render a manual, and we'll put it on frame 10 to give us we'll do a couple of test renders first, and we're just going to keep this at 720p for speed. Now let's go to Cycles 4D. Now Cycles 4D has lots of settings, and it's got lots of kind of intricate control over all kinds of things, from samples to denoising to AOVs, render elements, lots of cool stuff. But it could be a bit intimidating at first. But thankfully, you can get started with cycles only knowing 1 or 2 settings and leaving everything else on default. So first of all, let's go to device. If you have CUDA graphics cards in your rig, then you can select CUDA and it'll be really fast, much faster than CPU. So if I just twirl down device, I've got 2 1080 Ti's in my machine. So not the best cards in the world, but pretty good. So I've got mine set to CUDA. If you've got higher spec NVIDIA cards, you can go to optics, which is even quicker, but I'll keep mine on CUDA. And then we can shut that one down. We can shut all of this down, keep it on default until we get to the integrator menu. So all we're going to look at here is samples. Now the general rule with this type of render engine, a path tracer, is this: the more samples that you have in your render, the cleaner your image will be. It'll be crisp and you won't have as much noise, but the longer it will take to render. So by default, cycles are set to 4, which is hardly any. It's just for a default kind of draft render. It'll be very noisy. So what we'll do is we'll put this up to, say, 15. And 15 is going to give us a nice preview. It's still going to be a bit too noisy, especially in the kind of problem areas like the blurry areas, but it'll be a good starting point, okay? And we'll leave that and we'll shut it down. And everything else we're going to leave absolutely at default. We're not going to touch a thing. So let's leave it at that. And we'll go to render, render to picture viewer, and it's going to render frame 10. Of our animation. So here we can see I've got 2 graphics cards, and you can see they're working away, and there's a little bit of noise in the blurry areas, and I'm not sure if you can see due to the compression of this video, but there are some speckly areas here. And what these are a symptom of this type of render engine. They all do it. These are called Fireflies. So what we need to do is get rid of these Fireflies, and there's various different ways that you can do that. Upping the sample count can help, but of course that has a huge impact on how long it takes for your simulation to render. But we'll keep this going through. So we're on 15 samples here, and let's just move this along. So that took 51 seconds, which is, you know, a fairly long render. If you think that you have to do 90 frames for our animation, that's a fair amount of time. So let's address 2 things. First of all, let's get rid of these Fireflies. So the way in which we're going to get rid of these Fireflies is we're going to look at clamping the light. So let's switch off our picture viewer and go back to our render settings. So let's go back to our integrator and sampling, and we have clamp direct and clamp indirect. So what the main rule is, you want to clamp as little as possible because it's going to reduce the dynamic feel of your piece. It's going to kind of water everything down and the bright parts aren't going to feel as bright. So how it works is this: with 0 set in each window, the indirect and the direct light, there's no clamping whatsoever. If you put it at 1 in each, that's maximum clamping. It's clamped to 1, and if you increase it, it's going to lessen that effect. So let's just try putting our clamping to, say, 3 in the direct and 2 in the indirect. And we will, just to get a render out relatively a little bit more quickly, let's go to our samples and say put it down to 10. All right, so then let's go to render to picture viewer. Let's do one more. Okay, so you can see we've got a bit more noise because we've reduced those samples, but you can see with that clamping, all of those fireflies have now disappeared. So that's pretty good. And let's see how long this is going to take to do. Let's see the whole image. And that then is obviously a lot faster. That one took 24 seconds. Okay, very nice. So one final thing that we can look at, there is a fantastic feature. Let's have a look in our render settings again. There's a great feature now called adaptive sampling. So instead of it applying the same amount of samples to the entire image, adaptive sampling is kind of like smart sampling, where it throws more samples at the problem areas that need more samples, but then it doesn't waste those samples on areas where it doesn't need that much sampling. So the way it works is this: if we go to and click adaptive sampling, this sample amount remains the maximum samples it's going to use, but then we can put a minimum samples. So let's put the max to 20. Let's put the minimum samples to 10, which is that fast draft that we did. And then how it chooses how many to use within these two amounts is dependent on the noise threshold. The lower this number, the more likely it is to use the higher end, and vice versa. So let's put this on, say, 0.1. Okay, and we'll try that. So let's go to output now. Let's do all frames, and that's looking pretty good. So we'll come off there, we'll go render to picture viewer, continue without saving, and we'll leave that whirring away. So I'll pause this now. I'll come back to you when those 90 frames have finished. We'll have a look at that final render and we'll see how long it took. So that render has finished. It took 43 minutes and 39 seconds for all 90 frames. So it's around 30 seconds a frame to render that. And it's looking pretty good. So it's got decent quality. Obviously, there is still a little bit of noise in some of the areas that you would expect, like in the subsurface scattering areas and in some of the more blurry areas. But for the amount of time it took, our results are looking really nice. And of course, to get rid of that noise, used up the samples. So let's have a play through and see how it looks. We've got our animating geometry, which kind of works its way up. And we've got these really nice bits of light catching and scattering within that geometry as the camera rotates and as it grows. And that's looking really nice. And so you can see very, very quickly with a simple MeshTools setup, you can get what looks like an incredibly intricate bit of geometry and geometry animation. And all we've used is a couple of MeshTools layers and a couple of fields. And then, of course, Cycles 4D with almost the default settings. We have got this fantastic subsurface scattering look, and it's looking really nice, all rendered in under 45 minutes.